Hello students, hope you all are doing well. I am your Biswajit sir. Welcome you all to the first video of our series Oscillation series of our YouTube channel. Welcome you all to our first video. So today we will start from our chapter Oscillation. So here we will discuss about simple harmonic motions. The basics of oscillation we will start. What is simple harmonic motion, what are the different types, then we will discuss about the displacement, velocity, acceleration of simple harmonic motion. So hope you all are doing well, and let's start the series. So the first thing, before going to simple harmonic motion, we have to know some basics. One is the periodic motion. So periodic motion, you must have known about periodic motion. That means any motion which repeats itself in equal intervals of time. After a particular interval of time, if it repeats, the same motion is repeated again and again after a particular interval of time, that is said to be periodic motion. So that interval of time is said to be time period. Time period, capital T. So time period is what? Now it is the time in which the body or the vibrating object repeats its motion. Similarly, there is another term, frequency, and you must have known about the relation between frequency and time period. So frequency and time period are reciprocal of each other. Then another type of motion is that which is harmonic motion. So harmonic means if we can express any motion in terms of sine or cosine, trigonometry functions, sine theta, cos theta, like that, then that is said to be harmonic motion. So we can represent in terms of sine theta, or instead of theta, you can also write down omega t. Angular frequency or angular velocity, you must have remember omega t. Similarly, cos theta or cos omega t, if we represent, that is said to be harmonic motion. Another one is the oscillatory motion. Oscillatory motion is to and fro motion. For example, simple pendulum. So if the motion repeats itself along the same path about a fixed point, that is said to be oscillatory motion. So always remember, all oscillatory motions are periodic. All oscillatory motions are periodic in nature because they repeat the motion in a particular interval of time on the same path, to and fro motion, back and forth motion. But all periodic motions are not oscillatory. For example, motion of earth around sun. So it is periodic. After 1 year, again the repeat cycle starts. But it is not to and fro. I hope periodic, harmonic and oscillatory motions concept you have cleared. Then we will go to the simple harmonic motion. Simple harmonic motion, already you know that oscillatory motion, harmonic motion, periodic motion. Then what is simple harmonic motion? In simple harmonic motion, the motion should be periodic. That means it repeats its motion in a particular interval of time. Again, the motion should be harmonic and oscillatory also. Harmonic means which can be expressed in terms of trigonometry functions, and oscillatory means to and fro motions. And the different thing that you can also identify harmonic as well as oscillatory, because trigonometry function and oscillatory already you know. So in simple harmonic motion, the displacement and acceleration both are directly proportional to each other, but both are in opposite direction. So always, if you see this figure, displacement of the body, we have to displace the simple pendulum from its mean position on either side, on the right side or left side. That means we are moving the body away from the mean position of rest. Mean position means that equilibrium point is said to be mean position of rest. So when the body is moved from its mean position on either side, that means displacement is always on outward direction. So displacement is always away from the mean position of rest. Once we leave the body at a point, then you can observe that the body starts moving towards the mean position of rest due to that restoring force. So acceleration of the body is always towards the mean position of rest. So we can write acceleration is directly proportional to displacement, and since both are opposite direction, we can write A is proportional to Y, but there is a negative sign. So simple harmonic motion means the motion should be periodic. Motion should be to and fro along the same path about a fixed point. That fixed point, that equilibrium point, is said to be mean position of rest. And acceleration and displacement are directly proportional to each other. and there is a negative sign which indicates that both are in opposite direction. Again, you can see acceleration is always towards the mean position of rest and displacement is always away from the mean position of rest. I hope this concept is clear. Next, we will go to the next part, the differential equation. So, as we know that displacement and acceleration are directly proportional to each other. A is proportional to y, but there is a negative sign. If acceleration is directly proportional, we can write down that the force is also directly proportional to y, and there will be negative sign. So F equal to some constant k into y. This constant already you have studied in spring constant or force constant. But we know that force is equal to mass into acceleration. So you can write down mass into acceleration is d square y by dt square. This is the general for inertial force, mass into acceleration. Now we have a particular formula for simple harmonics, and this is the generalized formula for force. So we can equate both. So we can write F equal to, we have minus ky, and F equal to, we have m d square y by dt square. So we can equate m d square y by dt square equal to minus ky. So you can write down like that, d square y by d square equal to minus k by m into y. But k by m is a constant which you can write down omega, angular frequency. So here we can use omega instead of k by m. So our formula will be d square y by dt square equal to minus omega square y. So you can take this term to the left hand side, so it will be positive, d square y by dt square plus omega square y equal to 0. This is the differential equation of simple harmonic motion or SHM. Force directly proportional to y, and there is a negative sign because both are in opposite direction. So F equal to minus ky. So already we have the formula force equal to mass into acceleration. So we can write like this, m d square by dt square. We just equate, and here is a rearrangement. K by m we have written, and instead of k by m we can write down omega square. So d square by dt square equal to minus omega square y, and we can take that to the other side. So it will be positive. So d square y by dt square plus omega square y equal to 0 is the differential equation of simple harmonic motion. Next we will calculate the formula or the expression for velocity, expression for displacement, expression for acceleration. Always remember, when a body is in circular motion, uniform circular motion, its foot of the perpendicular executes simple harmonic motion about its mean position, or you can say the center. So what is foot of the perpendicular then? If a circular path is there and body is vibrating or oscillating or moving in circular motion, this body is moving. At any point, the body will move in circular orbit or circular path. But if we draw a perpendicular at any instant, let the particle is here. If we draw a perpendicular here you can see the foot of the perpendicular. When the particle will start from here to here, foot of the perpendicular will move from this point to this point. Again, if we increase, again the foot of the perpendicular will move up to this part. Again, at a point you can see foot of the perpendicular will reach there. Again, when the particle will move along this direction, the foot of the perpendicular will decrease up to the center O. Again, the particle will move and the foot of the perpendicular will move in downward direction. When the particle will complete this quadrant or this part, then the particle again move. So the foot of the perpendicular is moving like this, to and fro motion about the point O. So foot of the perpendicular always execute simple harmonic motion. So from here you can calculate the expression for displacement. Then we can go to the velocity as well as acceleration. If it makes an angle theta, then this angle will be theta. Let me name that as this point is A, this is B. So this is the displacement. So displacement Y we have to calculate. So from triangle O, A and B, this one, O, A and B. So sine theta already we know that this will be equal to P by H. So in this triangle P, let me write that formula first so that you can easily remember P by H. So P is nothing but O to A and H is O to B. Clear? So we need that OA which is equal to OB sine theta, but OA we have mentioned that displacement as y. Similarly, OB is nothing but this is the radius. If radius of the circular orbit is r, we can directly write down r. So this is formula. We can write down y equal to r sine omega t, where theta equal to omega t. You can also directly write down r sine theta. So this is the expression for displacement of simple harmonic motion, which is equal to displacement equal to r sine omega t, where r is the radius of that circular path, or in simple harmonic motion you can say this is the amplitude. So amplitude, what? The amplitude is nothing but the maximum displacement. Since it is sine, the curve will be like this. So this is the amplitude. This is the amplitude. So amplitude is nothing but the maximum displacement on either side of the mean position of rest. From mean position of rest up to this is r, up to this point also this is r. So this is said to be amplitude. Next we will calculate velocity. We have derived the expression for displacement, then we will go to velocity. From definition we know that velocity is rate of change of displacement. Already we have the expression for displacement, so we can directly write down r sine omega t. Since r is a constant, we can take that outside. Derivative of sine omega t, derivative of sine theta is equal to cos theta. Similarly, if any constant is multiplied, we have to multiply that. This will be omega cos omega t. So velocity formula we have derived r omega cos omega t. This is the expression for velocity. We can also rearrange this formula in order to find out in terms of directly y. How we can rearrange? See, v is there, r instead of cos omega t we can write down 1 minus sine square omega t square root. Then v equal to r, we can directly also multiply r inside. You can see like this. This is omega, in bracket we can write down r square, because outside the square root it is r. So if you move it inside the square root, this will be r square sine square omega t square. So here you can see this dot r sine omega t square. R sine omega t is what? R sine omega t is our displacement. Y equal to r sine omega t. So we can write like this: omega in bracket we have r square minus this is y square. So this is another formula for velocity, where we have put y equal to r sine omega t, the displacement. R sine omega t is nothing but the displacement. So we have used that here. So we have another formula for velocity. One is r omega cos omega t in terms of angle, or if in question only amplitude and displacement at any instant is given, then we can write down v equal to omega square root of r square minus omega square y square, not omega square root. Then we'll calculate the acceleration. So acceleration is very easy. Already you can write that acceleration is the rate of change of velocity. So here you can see velocity we have easily calculated. So we can write down d by dt of r omega cos omega t. So r omega is constant and derivative of cos omega t. Derivative of cos omega t will be minus omega sine omega t. So this will be minus omega square, here one omega, another here. So omega into omega, omega square, r sine omega t. Again you can see we have r sine omega t. So we can write down minus omega square y minus omega square y. So acceleration we get a equal to minus omega square y. Since angular frequency or angular velocity omega is a constant quantity, we can directly write down a proportional to minus y. This is what we discussed in simple harmonic motion. In simple harmonic motion, acceleration is always directly proportional to displacement. but both are in opposite direction. That's why there is a negative sign. So mathematically also we get the expression as a equal to minus omega square y. So a is proportional to minus y. I hope up to this everything is clear. Displacement, velocity and acceleration. Next we will express all these displacement, velocity and acceleration in graph form. So we have the expression y equal to r sine omega t. Similarly, we have the expression v equal to r omega cos omega t. Acceleration equal to minus omega square y equal directly line or direct formula r omega square sine omega t का रहेगा. So for plotting graph, we have y, v and a with respect to theta or omega t we can calculate. So you can make a table so that it will be easier for you to understand. Here we can write down omega t. So t also you can write down. Then the different values or y you can calculate, v you can write a, and the different values of omega t or angle you can directly write. Angle is nothing but 0 we can start, then 90 degree pi by 2, 180 degree pi, then 3 pi by 2 and 2 pi. Similarly for time period, total time is time period. Time period is nothing but the time taken by the particle to complete one cycle. So this is capital T. So half of that will be T by 2. Again starts from 0. This is T by 2. Its half will be T by 4. And this will be 3T by 4. Then we have to find out the values. See, we can directly use the values of omega t here. If omega t is 0, sine 0 is 0. So this will be 0. Then when you put omega t equal to pi by 2, sine pi by 2 is 1. So this value will be r. Similarly, sine pi is again 0. So y will be 0. Sine 3 pi by 2 is minus 1. So we will have the value minus r. Sine 2 pi is again 0. Now we get the values of y with respect to omega 2. Next we will go to velocity. When we put omega t here 0, cos 0 is always 1. So our result will be only r omega. So here we have r omega. Similarly, if we put pi by 2, then we know that cos 90 is 0. Again, pi is cos 180 or cos pi is always minus 1. So this will be minus r omega. Again 3 pi by 2, again 0, and cos 2 pi already you know this is plus. So plus 1 means r omega. Now these are the expressions for velocity. Similarly, we can calculate the expression for acceleration. Once we put the value similar to that of sine theta, here we have sine theta, here also sine theta, but difference is there is a negative sign. So this will be 0 because sine 0 is 0, sine pi by 2 is 1, so this will be minus r omega square. This will be again 0, sine pi, 3 pi by 2 is minus 1, here is another minus, so minus 1 is plus, this will be r omega square, this is again 0. Now we have the values of y, v, a with respect to omega t. Our next work is to draw the graphs. To plot the graph, first one is we can plot for displacement along y-axis and omega t along x-axis. Y-axis, y dash, this is origin of 0, this is x-axis. Now we have to plot. Let point out, let this is pi by 2, pi, 3 pi by 2, 2 pi. The points you can see, when omega t is 0, displacement is 0. So point is here. When omega t is pi by 2, displacement is r. Let this is r and this will be minus r. So this point will be here. At pi 0, at pi it's 0. Then at 3 pi by 2 it is minus r. So point will be here. Then at 2 pi it is 0. Again it's 0. So we have to just connect the dots. Once we connect, we will find out a sine curve. So this is the graphical representation of displacement. Similarly, we can plot the graph for velocity here. Velocity along y-axis, right? And here omega t. Same thing, 0, then pi by 2, pi, 3 pi by 2 and 2 pi. Clear? Now we have to plot. For velocity at 0 it is r omega. Let this value is r omega. R omega, this will be obviously minus r omega. Now we have to find out the plot points. When angle is 0, this is r omega. So point will be here. But 90 point is 0. So this is at pi, the value is, you can see, minus r omega. So here minus r omega. At 3 pi by 2 it is 0. So here at 2 pi it is again in positive side here. So if you plot the graph, this will be like this. So this is a cos curve. Similarly, last one we can plot with respect to acceleration. So if in acceleration we plot, let acceleration along y-axis, y dash, this is the origin, this is x, and angles are like pi by 2, pi, 3 pi by 2 and 2 pi. So acceleration is 0 at 0. You can see at 0 it is 0. At pi by 2 it is minus r omega. At pi it is 0. So accordingly you can plot at pi by 2 minus r omega. Let this is minus r omega square. This is r omega square. So this point will be here. At pi it is 0 means here 3 pi by 2 is positive means here 2 pi 0. So this is the graphical representation of acceleration. So one more thing here you can identify, in acceleration we starts from the negative goes to the positive, but here in displacement we starts from positive goes to negative because there is a negative sign. From the definition also we understand that both acceleration and displacement are opposite to each other. So from graphical representation also we identify the same thing or same pattern. Hope you understand about all these things: displacement, velocity, acceleration, expressions, then the graphical representations. So in next video we'll start from the damped oscillation or damped vibration case. We'll discuss about what is damped vibration, how the different forces are involved, what is the wave equation and its solution. In next video we will start. So thank you.